So what's the main idea behind Newton's second law of motion? The basic idea behind it is that the acceleration of an object is directly proportional to the net force, and it's inversely proportional to the mass of the object. Perhaps you've seen this equation. The net force is the product of the mass and the acceleration. So the acceleration is equal to the net force divided by the mass. So if you increase the value of the net force, the acceleration will increase. Now, whenever you increase the numerator of a fraction, the value of the entire fraction increases. But when you increase the denominator of a fraction, the value of the whole fraction decreases. So if you increase the mass of the object, the acceleration will decrease, provided that the net force is constant. So thus, we could say that acceleration and force are directly proportional to each other, and the acceleration is inversely related or inversely proportional to the mass of the object. So, if you double the force, what's going to happen to the acceleration? If you increase the net force by a factor of 2, the acceleration will double. If you increase the net force by a factor of 3, the acceleration will triple. Now, if you double the mass, the acceleration will be 1/2 of its original value. So it's going to decrease by a factor of 2. If you triple the mass, the acceleration will decrease by a factor of 3. So it's important that you understand that. So let's say if we increase the force by a factor of 4 and we increase the mass by a factor of 2. By what factor does the acceleration change? To answer a question like this, just plug it into the formula. So it's going to be 4 divided by 2. The acceleration will increase by a factor of 2. If something doesn't change, replace it with a 1. So let's say if the force, let's fix that. Let's say if the force increases by a factor of 8 and the mass is reduced to 1/2 its value. What's the acceleration? It's going to be 8 divided by 1/2, which if you multiply the top and bottom by 2, this is 16/1. So the acceleration will increase by a factor of 16. So if you decrease the mass, the acceleration will increase if the net force is constant. Now let's say if we have a box and we apply a force on this box. What is the direction of the acceleration? So what is the direction of the acceleration vector? Acceleration and the net force always act in the same direction. So the acceleration is going to be in this direction. Now let's say if there's a 5 kilogram block that rests on a frictionless surface and you apply a force of 40 newtons. What is the acceleration that's acted on the block? And what's the direction of the acceleration? So using the equation, the net force is equal to ma. The only force acting on the block is the 40 newton force, so that is the net force. The mass is 5 kilograms, and so the acceleration is going to be 40 divided by 5. So it's 8 meters per second squared. And the acceleration is in the same direction as the net force. Now here's another question. So let's say if you have an 8 kilogram block and you apply a force of 35 newtons west, and this time the block is on a surface that contains friction. Friction opposes the motion, let's say with a force of 19 newtons. part A, calculate the net force, and part B, calculate the acceleration and determine the direction of the acceleration vector. So to find the net force, we need to find the sum of all forces in the x direction. Now, this force is acting in the negative x direction, and this force is acting in the positive x direction. So I'm going to say positive F plus negative F. This is negative because it's going towards the left. This is positive, it's going towards the right. So the sign is based on the direction where the force is being applied. So the net force in the x direction is going to be F, the frictional force, minus the applied force. The frictional force is 19 newtons. The applied force is 35 newtons. So the net force in the x direction, or the sum of all forces in the x direction, is negative 16 newtons. So this is the answer to the first part of the problem. Now here's a question for you. If I asked, what is the magnitude of the net force, what answer would you report? If you get a test question to ask you only for the magnitude of the net force, you need to report positive 16 newtons. The magnitude of a vector is always positive. The negative 16, the negative sign tells you the direction, that the net force is due west. So you could say 16 newtons west, so you have the magnitude with direction, or you could just say negative 16 newtons, which will indicate it's going towards the left. So now what is the acceleration? So once you have the net force, you could find the acceleration, in this case, in the x direction. The net force is m times a. So if this is in the x direction, this has to be in the x direction. The acceleration is always in the same direction as the net force. So it's going to be negative 16 newtons divided by the mass of 8. So the acceleration in the x direction is negative 16 divided by 8. So it's negative 2 meters per second squared. So the negative value tells us that the acceleration vector is towards the left. And it makes sense. The net force is negative 16. So that means the net force is directed towards the left. And based on Newton's second law, the acceleration vector and the net force vector, they have to be in the same direction. In this case, they're both pointing towards the left, or in the west direction. So let's say if we have an object and that object is moving towards the right. So the velocity is positive. And let's say the net force acting on the object is also acting towards the right. What's going to happen to the object? If the force and the velocity vector are in the same direction, the object speeds up. So it's accelerating. Now, what's going to happen if the object is moving to the right and the force is directed towards the left? Whenever the force and velocity vectors, if they're opposite in direction, the object will slow down. So in this case, it's decelerating. Now, what's going to happen if you have an object that is moving to the right, but if the force vector is perpendicular to the object? What's going to happen? Anytime the force and velocity vectors are perpendicular, the speed will not change. It's not going to speed up and it's not going to slow down. Rather, it's going to turn. So it simply changes direction when the force and velocity vectors are perpendicular. So it's going to change, it's going to turn in the direction of the force. So now, the ball is moving this way. So if the force vector doesn't change, if it's still in that direction, now it's going to speed up. So initially, at this instant, at point A, it's not speeding up. But once it reaches points B, it's already speeding up. Now, while it's turning, it will begin to speed up in this direction. But when it's exactly perpendicular, it doesn't speed up at that instant. Now, let's work on some problems. Here's the first one. What average force is required to accelerate a 5 kilogram block from rest to a final speed of 54 meters per second in 9 seconds? So we can start with a picture. And so we have a 5 kilogram block, and we're going to apply a force of some value that we don't know. We're looking for it. And we'll give it some other information. We have the final speed and we have the time. How can we calculate the force? Now, it's helpful if you write down what you have and what you need to find. We know the initial speed is 0. It starts from rest. The final speed is 54 meters per second. And the time is 9 seconds. We don't know the acceleration and we don't know the force. In order to calculate the average force, we need the acceleration. Now, we have to assume that friction is not present because we don't have any information to determine what it is. So we're going to assume that the applied force is the only force acting on the block in the x direction, and so that's going to represent the net force. So let's focus on calculating the acceleration of the block. What equation contains these 4 variables? Hopefully you've reviewed kinematics at this point. Vf is equal to Vo plus At. So the final velocity, which is 54, that's equal to the initial velocity of 0 plus the acceleration multiplied by the time. So the acceleration is 54 divided by 9, which is 6. So it's 6 meters per second squared. Now, let's move on to the second part, now that we have the acceleration. So the force is going to be the mass of 5 kilograms times the acceleration of 6 meters per second squared. And 5 times 6 is 30. So it's going to be 30 newtons. So that is the net average force that is required to accelerate the 5 kilogram block from rest to a final speed of 54 meters per second in 9 seconds. Now let's move on to number 2. A 1500 kilogram car moving at a speed of 45 miles per hour comes to a stop after traveling a distance of 200 meters. What was the average force exerted by the brakes on the car? So I'm going to use a box to represent the car, because the box is just very simple to draw. And so the mass of the car is 1500 kilograms. Now the car is moving at a speed of 45 miles per hour. Now it comes to a stop, which means it's slowing down until it stops. So therefore, the force that brings it to a stop is opposite to the direction of the velocity. Because remember, if force and velocity, if they are in the opposite direction, then the object slows down. Now, it's going to take a stopping distance of 200 meters to slow it down completely to a stop. So our goal is to find the average force. So if we could find the acceleration, we could find the force. So let's make a list of what we have. We know the initial speed is 45. Actually, before we do this, let's convert miles per hour to meters per second. So we have 45 miles per 1 hour. And 1 kilometer is 0.6214 miles. And 1 kilometer is also 1,000 meters. You want to set it up in such a way that the unit miles cancel. And also you want kilometers to cancel as well. So right now you have meters. If you don't understand this, you may want to watch my video on metric system review and unit conversion and dimensional analysis, which I'll teach you how to convert from one unit to another. Now let's convert hours into seconds. So 1 hour is 60 minutes, and 1 minute is equivalent to 60 seconds. So now the unit hours cancel, and also minutes cancel. So what we have left over is meters per second. So now let's do the math. We're going to multiply by the numbers on top and divide by the numbers on the bottom. So it's 45 divided by 0.6214 times 1,000 divided by 60, and then divided by 60 again. So you should get 20.1 meters per second. So now let's write down what we have. So this is the initial velocity, 20.1 meters per second. What's the final velocity? Now we know the object comes to a stop, it comes to rest. So the final velocity is 0. We have the displacement, which is 200. And our goal is to find the acceleration. Once we find that, we could find the force. So what kinematic formula has these variables? The equation that you need is V final squared is equal to V initial squared plus 2AD. So V final is 0, V initial is 20.1, and D is 200. 20.1 squared, that's 404.01, and 2 times 200 is 400. So I'm going to take this number and move it to that side. So it's going to be negative 404.01, and that's equal to 400A. So if we divide both sides by 400, you'll see that the acceleration is negative 1.01 meters per second squared. Now the reason why it's negative is because the object is slowing down. The force is directed towards the left, so the acceleration is also directed towards the left, and that's why we have a negative value. Now that we have the acceleration, we can calculate the average force. So F equals ma. It's going to be the mass of 1,500 kilograms times the acceleration of negative 1.01. So the average force is negative 1515 newtons. It's negative once again because it's directed towards the left. It's slowing the car down to a stop. And so that's it for this video. Hopefully it gave you a good idea of Newton's second law, which is basically F equals ma. Acceleration is directly proportional to force, but acceleration is inversely related to the mass. And keep in mind, the direction of the acceleration and the force vector is the same. And now you know how to solve some problems using the F equals ma formula.